All right, hello and welcome. This is going to be your homework help video for equations, inequalities, and absolute values quiz review. Just going to try and go through one of each question type here. The question I want to do in this first section is our proportion. A lot of people see proportions and they think they have to use some sort of trick to solve them. There is the trick of cross multiplying, but I'm just going to show you how you could solve this without a trick. Problem number 5 here. So problem number 5 says 6 over x equals 5 over 4. I want to get the x by itself, but it's in the bottom of a fraction. So a way that I could get it out from underneath that fraction is to multiply both sides by x. This would cancel out the x on my left-hand side and be left with 6 on that left-hand side. And when I multiply a number to a fraction, it can just go on top of that fraction. So on the right-hand side, this would become 5x over 4. To keep solving this, moving things away from x, I'd probably want to multiply both sides by 4. Now I've got 24 equals 5x. Divide both sides by 5. And I get 4.8 equals x there. So yep, that checks out. Let's look down here where we're solving absolute value equations. I'm going to pick problem number 14 because we've got an operation outside of our absolute value brackets and it's a division problem. So when I start with the absolute value of negative 8n over 10 equals 2, the first thing I want to do is move that 10 to the other side. It is dividing everything on this side, so if I multiply both sides by 10, it will cancel out. And now I'm left with the absolute value of negative 8n equals 20. Now that the absolute value bracket is isolated, I'm going to split this into two different scenarios. The first scenario, I just drop the absolute value brackets entirely. And in the second scenario, I replace the absolute value brackets with the negative parentheses, being sure to change nothing else about the problem. The only difference between this here in pink, this here in brown, is that the absolute value brackets have turned into parentheses and I've got a negative outside. Now I can just solve these separately. Divide both sides by negative 8 here. Look at that n equals, is that negative 2.5? And over here I'll get that the negative times a negative becomes a positive. 8n equals 20. Divide by 8, divide by 8. And I get that n equals 2.5. Number 14, let's just double check that one. They left us 5 halves, that's fine. All right. Draw a graph for each inequality. X is less than or equal to negative 2. I go to, or positive 2. I go to 2 on my number line. I put a dot. I look at the symbol. It has the or equal to, so I fill it in. Variables on the left-hand side, so I can use the trick that the inequality points in the direction my arrow needs to go. Arrow's coming this way. Test it with a point. Let's try negative 3. Is negative 3 less than or equal to 2? Yep, that checks out. Write an inequality for each graph. I look at where the endpoint is. So I say x, and then I look at the endpoint. The endpoint's at negative 4. Then I look which way it's pointing. It's pointing towards the smaller numbers, so I want to make this a less than. Am I including my endpoint? Yes, I want to add that or equal to part. Solve each inequality and graph its solution. Let's see, we've got 2 more on this page. Maybe 21 looks a little more challenging. Actually, do I have an example? Yeah, we'll do 21. First thing I want to do here is move away just constants. The thing is, this 6 and this 123, they are like terms, but they're on opposite sides of the inequality, so we have to use an inverse operation to combine them. So I'm going to subtract 6 from both sides, and now I'm left with negative 3 parentheses negative 7x minus 4 is greater than or equal to 117. Now, So if people ask me if they should distribute this -3 versus divide it away, it's going to be the same either way. I notice that I've got another negative inside, so I'm going to go ahead and distribute this here so that I get positives. But the other way is fine as well, to just divide both sides by -3, but I'm going to distribute. And that's going to give me the equation 21x plus 12 is greater than or equal to 117. From here, I'll subtract 12 from both sides, again, trying to combine my like terms. I'll get 21x is greater than or equal to 105. Divide both sides by 21. And we get that x is greater than or equal to 5. Put a dot at 5, fill it in, arrow coming this way. All right, solve each compound inequality and graph its solution. So for these, we just want to solve them separately and then keep the correct word in between them. I'll do our OR problem. It's the only OR problem in here. So I want to just kind of solve these each separately. The 9x minus 9 less than or equal to 36. To solve that, I'm going to add 9 to both sides. 9x less than or equal to 45. Divide both sides by 9. X is less than or equal to 5. So that's part of our answer. Over on this side, 2x minus 8 greater than or equal to 12. Add 8 to both sides. 2x greater than or equal to 20. Divide both sides by 2. X is greater than or equal to 10. Let's keep that word or in between them. So x is greater than or less than or equal to 5. Put a dot at 5, fill it in, arrow coming this way. X is greater than or equal to 10. Put a dot at 10, fill it in, arrow coming this way. And notice it leaves a gap just like we expect OR problems to do. OR problems do not rely on overlap. We actually don't want there to be overlap, or else we get something that's just all real numbers. All right, solve each inequality and graph its solution. Let's do one that's got multiple terms on the outside. Let's do number 30. So with number 30 here, I see a lot of people trying to combine this 6 and this minus 3. We cannot do that. It goes against our order of operations. Those numbers are not to be combined until after this 3 does its multiplication, which we can't do because we can't multiply into an absolute value bracket. So what we're going to do is we're going to subtract 6 from both sides. Now I've got -3 absolute value of -3v greater than or equal to -54. And now I'm going to divide both sides by -3. So that I got rid of the 6 by subtracting 6. I'm getting rid of the 3 by dividing by -3. These will cancel out. And on this side, I'll get, what is that, 28. So absolute value of -3v greater than or equal, or just greater than 18. I just want to double check that. 54 divided by 3, 18. Okay. Now that I've got the absolute value bracket isolated, I can split it into the two cases. This case where I just drop the brackets entirely, -3v is greater than 18. In the case where I replace them with the negative parentheses, -3v is greater than 18. On this side, I got to divide both sides by -3. V, sign flips, is less than -6. And on this side, the negative times a negative becomes a positive. Divide both sides by 3, and we'll get that v is greater than 6. Just like that. Let's take this to the graph. I go to -6, make a dot, leave it open, arrow going to the left. Go to +6, make a dot, leave it open, arrow going to the right. This is an OR problem. Is it an OR problem? Let's just double check that one. 30, no, I made a mistake here. -6. That's the wrong problem. Everybody probably spotted my mistake. This one's screaming at their computers. Oh, right here. We divided by a negative. So we should have flipped the inequality here, meaning that these inequalities are facing the wrong direction. Yeah, you guys probably been screaming at your computers. You forgot to flip your inequality there. And then here it's going to flip back. Here it's going to stay facing this direction. And when we go greater than -6, it comes this way. When we go less than 6, it comes this way. These meet up to make a line segment, making this an AND problem. Let that be a lesson. I'm not going too quickly to my future self. All right. Yeah, since we botched that one, let's just do one more. We'll do 31. For 31, I want to get my operations away from the absolute value bracket. I do that by adding 2 to both sides to get rid of that 2. Now I've got 2 absolute value of 8 plus x is greater than or equal to 36. Divide both sides by 2. Absolute value of 8 plus x greater than or equal to 18. Split it into the 2 cases. One case where we drop the brackets entirely, 8 plus x greater than or equal to 18. And one case where they become a negative parentheses. Negative parentheses, 8 plus x greater than or equal to 18. In this one here, we can just subtract 8 from both sides. We get that x is greater than or equal to 10. It's part of our answer. In this one over here, we divide both sides by -1. Get that 8 plus x is less than or equal to -18. Subtract 8 from both sides. X less than or equal to -26. Let's go to the graph. X is greater than or equal to 10. Closed circle at 10. Arrow coming this way. Less than or equal to 26. Closed circle at 26. Arrow going this way. This was an OR problem all along. Let's check I did 31 correctly. Yeah, that looks better. Okay. Convert the following compound inequality to an absolute value inequality. So what we need is we need the midpoint halfway between 44 and 50, and we need the tolerance. So let me just put that on a number line real quick. 44, 50. We've got a line segment in between. The endpoints are closed. Halfway in between 44 and 50. Let's see, that's a distance of 6, so it would be 47. That way we're 3 above and 3 below that. All right, so 47 is our midpoint, and we've got a tolerance of 3. So here's how we do it. We always do x minus our midpoint instead of absolute value brackets. If it's an interval like this, it's going to be less than. The endpoints are closed. We make it an or equal to. Then we put the tolerance over on the other side. The absolute value of x minus 47 is less than or equal to 3. Convert the following absolute value inequality into a compound inequality. All right, so go in the other direction. Divide both sides by 4 to start. Absolute value of x plus 3 is greater than 4. Split into the 2 cases. X plus 3 is greater than 4, and negative parentheses x plus 3 is greater than 4. Subtract 3 to both sides. We've got x is greater than 1. On this side, I might divide both sides by -1 to get started here. X plus 3 is less than -4. Sign's got to flip. Subtract 3 from both sides. We get that x is less than -7. And to make it a compound inequality, we've got to join those with the right word. Well, can you be bigger than 1 and less than 7 at the same time? No, so this has to be an OR problem. the fact that a plus b, if a plus b equals b plus a is what property of equality? This is our symmetric property of equality. Double check that one. Symmetric, yep. Yeah, it kind of looks like a mirror is being held up in between the two equations. Well, okay, good luck studying, and I will see you for the quiz. Bye.